For years, the leading labs in the United States maintained a consistent stance. Frontier models like Claude Fable and GPT 5.6 Sol were described as too powerful and dangerous for public release. To ensure safety, the underlying weights of these models were kept safely locked away behind proprietary APIs. That control over the frontier shifted in July 2026. A Chinese lab called Moonshot released Kimi K3, a model featuring a 1 million token context window and a massive 2.8 trillion parameters. It matched the scale and reach of the most advanced American systems. But instead of putting K3 behind a subscription wall, Moonshot uploaded the entire architecture to the internet. They gave the weights away for free, providing the public with an open-source tool of frontier-level complexity. This release directly challenged the protective moats built by Silicon Valley. It took Moonshot only a few weeks to match the performance of models that the US government had previously deemed too sensitive for the common man to use. By releasing the weights directly, Moonshot effectively bypassed the gate-kept distribution model of American labs. This shift forces a recalculation of how global AI power is distributed when the most complex models no longer require corporate permission to access. This conceptual nap shows how a 2.8 trillion parameter system functions without collapsing under its own compute requirements. It uses a mixture of experts architecture, where a central node acts as a dispatcher, routing the data to specific, specialized subnetworks. In Kimi K3, that grid is composed of 896 individual experts, the vast majority of which sit idle during any single request. For every token the model processes, exactly 16 of them activate. It functions like a large corporation, where a small team of 16 programmers performs the actual labor, while 880 other managers remain inactive. This selective activation allows K3 to scale 2.5 times more efficiently than Moonshot's previous model. However, the efficiency wasn't enough to handle the initial surge of users, which quickly exhausted the lab's GPU capacity and forced them to turn away paying customers. This architecture demonstrates that extreme AI scale is achievable without the proportional increase in brute force energy. It changes the economic requirements for building and maintaining a frontier-class model. This bar chart shows K3's standing on the front-end code arena, where it reached an ELO of 1,679. Based on these initial benchmarks, it appeared to be taking the #1 spot over Fable 5 and GPT 5.6 Sol. However, these results were produced using Moonshot's own Kimi code harness. Competitors were evaluated using different testing frameworks, which likely provided K3 with a home field advantage that skewed the final rankings. Independent audits reveal significant performance gaps. This gauge illustrates a 51% hallucination rate, measured by artificial analysis. Furthermore, K3 trails American models by 10 points on the Humanities Last Exam benchmark, and often produces an excessive number of redundant tokens. There is also the issue of hardware. While the weights are open, running a 3 trillion parameter model is impossible on consumer hardware. Gaining full access to K3 requires a massive array of data center caliber GPUs, placing it out of reach for the average home user. K3 produces high-end coding output on paper, but the combination of a coin flip error rate and enterprise hardware requirements limits its current utility. It functions as a volatile research experiment rather than a polished consumer product. This release has created a role reversal in global AI policy. At the World AI Conference, China's Communist Party became a prominent advocate for the free and open distribution of artificial intelligence. In the United States, the trend is moving in the opposite direction. Industry leaders are now lobbying for increased regulation, arguing that open weights are a threat to safety and progress. This tension mirrors the tech battles of the 1990s. This image shows Microsoft's Steve Ballmer, who famously fought against open-source software like Linux, labeling the movement as communism to protect his company's proprietary interests. The fear of losing market share to open models has prompted calls in Washington to ban Chinese AI labs. As shown on this Polymarket graph, the probability of an outright ban is currently at 29. Alibaba recently entered the fray with Qwen 3.8, a 2.4 trillion parameter model that also offers open weights to the public. The AI arms race has entered a phase where sheer parameter count is weighed against accessibility. The survival of the open source movement now depends on its ability to navigate hardware bottlenecks and looming government crackdowns.